This is actually the egress. This is actually when I'm coming out. What I had tried to do was actually fly with the gun or maneuver with the gun right out of the spacecraft. And when I departed the spacecraft this time, there was no push-off whatsoever from the spacecraft. The gun actually provided the impulse for me to leave the spacecraft. The first time I tried to come out, there I go. Right now I'm leaving, and it's under the influence of the gun. I'm trying to maneuver over to my left so I would be in front of Jim's window. I maneuvered approximately down the center line of the spacecraft, perhaps favoring just a little on the right. But the gun is actually providing the impulse for my maneuvers. I started a yaw around to the left with the gun. At this time, I knew we had something with the gun because it was actually providing me an opportunity to control myself where I wanted to go out there. The control was actually what we were trying to demonstrate on our EVA operation. We knew a little bit about the tether dynamics, but we wanted to actually find out how well could a man outside a spacecraft with a maneuvering unit control himself. And in the later parts, we wanted to find out just how well could the man control himself with a tether also. It looks like right now I've started to float up, and this is the influence of the tether. It always tried to drift me up above the spacecraft, away from the area that I wanted to be in. I think at this time I was translating back toward the spacecraft. I came back toward the spacecraft, up over the hatch, turned around above the spacecraft, out of the view of the cameras, and this time I told Jim I was coming back again out in front of the spacecraft to see if we couldn't be sure that we could record it on the cameras. This is the section that I recall I should come in from the left side. There it is. I see it. I'm coming in now, and I went out in front of the spacecraft at this time and actually made a yaw either direction. I found that the control with the gun to the right and to the left was what I felt quite adequate, and the pitch was quite adequate. I only had 6 feet per second in the gun, which is a very limited amount of air, so I tried to use it very sparingly. I just used it enough to satisfy myself and to make maneuvers so that I felt in my own mind that I could control myself in both pitch, yaw, and translation. This is the type of control that you need to move from point A to point B in space. If you can control your pitch and your yaw and translate fore and aft, you can actually go from point A to B. Roll really isn't very important. The roll didn't bother me. I wasn't trying to control myself in roll because we don't really care about the roll as long as the pointing direction is accurate.
In what seemed now a Gemini tradition, the launch vehicle lifted cleanly from the pad, accelerating the spacecraft towards orbit insertion and a rendezvous with Gemini 7. Then began the delicate out-of-plane maneuvers necessary to bring Gemini 6 into the same orbit as Gemini 7. After approximately 6 hours, rendezvous occurred.
6 and 7 Hawaii will be standing by if you have anything for us. Roger. There seems to be a lot of traffic up here, that's all. All the policemen. It's pretty exciting during the terminal run.
Ask them what their range is now.
6, what's your range? 20 feet. Or rather, 20 feet, right? We did it.
Gemini 6, Houston, Capcom, standing by. Roger, we're interested in your status.
Yeah, we're in formation with 7, everything is still here. Roger, congratulations, excellent. Thank you, a lot of fun. You guys really a shot, you look at droop almost wires right now. Stop draping it on me. Where are they hanging from? Frank, it looks like it comes out at the separation plate. It might be the fiberglass. It's approximately 10 to 15 feet long.
Gemini 6, ASQ Capcom.
Good,
Roger, Tim. Gemini 7, are you able to see in the windows of 6 very easily and vice versa?
Roger, 7 here. Flight away.
We copy.
Do you want to go ahead with this flight plan update to each of them, or do you want to just hold off?
I asked him if they're ready to copy.
Okay. 7 away. Go ahead. I got a short flight plan update if you'd like to copy it.
Stand by.
Go ahead, away. Okay. D4, D7. 2, 6, 5, 4, 3, 0, 0.
Don't forget the tape dump.
4, 2, 7.
Are you getting a tape dump?
Getting that flight.
Roger that.
Flight, did you copy that? Sensor got a little wet. It may have been reading high, but when we came back with these others, it was right around 68 degrees.
Roger, we read that, CSQ.
Okay, we want to keep both P pumps on and both suit fans on. We think it's condensation in the suit. And let's check further. Okay, thank you. And you know, our suit inlet temperature gauge is evidently offline also. Roger, our left suit reading is pretty erratic. It's running between 55 and 70 normally. Okay, our gauge is off scale low, below 40 degrees, so that's not that cold. Roger. Flight CSQ, the right suit inlet temp on the ground is 58.5 and stable. The left suit reading we have on the ground appears to be erratic.
Okay, in your summary, it's indicating 65.
You just have to catch it at that point. It's going anywhere from, well, it's got a wide range here. 50 to 80.
Roger. Both spacecraft go there, CSQ?
Say again, flight.
Are both spacecraft go?
They are both go.
Roger.
Flight, you copy all the readings he read on the temp survey?
You can put them in your post pass, Chuck.
Okay, it'll be a little late. I'll have to make a tape playback. I missed a couple of them.
That's okay. We'll wait for them. CSQ, Capcom, Houston flight.
Go ahead, flight.
Roger, we'd like a couple of sidewall temperature measurements from spacecraft 7. That's actual contact with the wall.
Roger.
We concur in that, sir, TV.
We concur. Now the number.
This is onboard film after completion of rendezvous. We are looking out the left or command pilot's window during the station keeping exercise. The film is shot at 6 frames per second, or 4 times normal speed. In the 4th revolution, just west of Hawaii, command pilot Armstrong reported that he had rendezvoused and was station keeping at 150 feet. The crew reported no difficulty in maneuvering in the vicinity of the Agena as they continually checked out its condition. No motion in the orbit of Agena was observed. Later, Colonel Scott would report at a press conference that the Agena was solid as a rock up there. Station keeping continued for about 35 minutes. Near the end of that time, command pilot Armstrong began to move in closer to Agena in preparation for his final docking approach. Both spacecraft and Agena are traveling at approximately 17,500 miles per hour. He moves in slowly and comes within approximately 40 feet of his target vehicle in this film sequence. The onboard camera is turned on again as Gemini 8 lines up with the target docking adapter of Agena. Ahead, the approach lights reflect red. Mr. Armstrong makes a final docking approach by applying small thrust increases to his velocity, about 1 foot per second. The command pilot will dock at 6:16 Eastern Standard Time. He will then perform a successful 90-degree yaw with the Agena. For 27 minutes, there will be no difficulty or hint of impending trouble. When Gemini 8 is about 2 feet from the Agena, it will pause. The Rose Knot Victor off the east coast of South America checks the telemetry. Now the Capcom gives the command pilot a go. You are looking good. Go ahead and dock. And there it is. He is docked. The first docking in space. 7 hours after liftoff, an excessive yaw and roll motion occurred. With the spacecraft attitude thrusters off, the crew suspected the problem was in the Agena attitude control system. Unable to isolate the source of the difficulty there, the command pilot made a decision to undock. With remarkable skill and coolness, he disengaged his spacecraft. The roll rate on Gemini 8 began to build up. It reached about 1 revolution per second. The crew members were experienced test pilots, and neither approached a loss of orientation. To bring his spacecraft under, command pilot Armstrong was forced to fire the re-entry control thrusters.